and slope of the least squares regression line. So for B numbers 6 and 7, that was unit 7, and for A number 8 was unit 7. You can use your graphing calculator. This formula sheet that I've let you use on the test is also available. Probably won't use this stuff a whole lot since you have your graphing calculator, but like this formula for the slope of a regression line, correlation times standard deviation of y over standard deviation of x might be useful. General probability rules, we'll talk more about these, but these two right here in particular might be important to use. And then generally speaking, the general ways to find a test statistic like a t or a z-score and the confidence interval. And then it shows you the general standard error formula. So sigma over square root of n would be s over square root of n would be standard error. Sample proportions. Okay, we'll review these as we get through unit 5 and 6 in those packets. And then the chi-squared statistic. And of course there's also the formulas on there. So then here's what the exam looks like. There will be 40 multiple choice questions that you have 90 minutes to do and 6 free response questions that you have 90 minutes to do. So you won't be able to combine the times, so you'll be given 90 minutes separately to do the multiple choice and then 90 minutes to do the free response. For the free response, there's basically 5 kind of normal sized questions that probably take around 10 minutes each. And then there's one, what they call an investigative task. The number 6 question usually starts out with some very doable things, but then partway through kind of switches over and probably asks you to generate some new ideas. So do your best on it. Make sure you get to all the questions and spend your time on doing the parts that you know how to do. And as you have extra time at the end, go back and maybe try to figure out those more difficult parts. Any questions about the exam itself? My biggest advice is think of this when you're deciding on inference procedure problems. So if there's something that says, is there evidence of this? Or come up with a confidence interval for this. Think about what we did this semester and decide which procedure to use. Is the data that they gave you quantitative or categorical? If it's categorical, is it about 1 or 2 proportions? Or is it more than that where there's a bunch of counts? If it's 1 or 2 proportions, you might do a 1 proportion z-test or a 2 proportion z-test or interval. If it's more than that, you ask yourself, okay, is the data organized in a 2-way table? If it is, then you're going to do a chi-squared test for independence or homogeneity. Chances are it's going to be tests for independence. I've looked at a lot of sample questions and tests over the past years. I've never seen a test for homogeneity. If it's not, it might be where you're given a model and given some counts, like the model of the M&M distributions, what percent are in each color. Then you do a chi-squared goodness of fit. If the data you have is quantitative, you ask yourself, how many variables are there? If there's 2 variables, think of like regression. So like we looked at, heights and weights of people. That's 2 different variables, height and weight. So you might make a scatter plot and do a regression t-test. If there's 1 variable, chances are it's going to be about the mean. Okay, don't confuse 1 variable with 2 means, 2 variables. So if like we're comparing heights of, people in Wisconsin versus heights of people in Minnesota, that would be 2 populations that we're drawing samples from, but there's still 1 variable, heights. Pretty much always sigma is not known, so we're going to do a t-test for means, a one sample t-test if we just are trying to figure out is the mean this, or is there evidence that the mean height is bigger than this or smaller than this? Or if there's two samples, then we do either a matched pairs t-test or a two-sample t-test. So once you decide on the proper procedure, then you have to know all of your assumptions and conditions. And this is actually in the back cover of your textbook. This is the one side, and then on the other side they have the formulas. You'll have to memorize these assumptions and conditions. Okay, so think about pretty much a common theme is we're assuming that the individual data values are independent, and then something about often our sample is large enough. So for proportions, that was the key thing. The individuals are independent and the sample was large enough. We check that with the independent idea with random sample that's less than 10%. That's a common one. Remember that. The large enough for proportions, we have to check the success failure, n times p and n times q, and make sure they're at least 10. If we are doing a two proportion z-test, we just have one extra thing to check, that the two groups have to be independent from each other, and then we check those other things within each group. So you check randomization and 10% for the one group, and then the second group, and then you check that the success failure for each group. Or, like if it's a controlled randomized experiment, the random assignment to the treatment groups takes care of the independent idea. So if we have means, if we're doing a one sample t-test or a two sample t-test or a matched pairs t-test, we basically have the same thing. Are they independent? So we check that with randomization and 10%. But instead of the large enough, we can kind of use the large enough. The large enough might be about 30 or higher, because then the central limit theorem applies. But if we have a sample that's smaller than 30, we have to be able to assume that the population is normally distributed, so we make a histogram and check that it's roughly unimodal and symmetric. If we're doing a matched pairs test, we just have to verify that we have matched data, and then we do the same thing. But we do everything on the paired differences, so we create a third list of the differences. If we're doing a two-sample t-test, the other assumption is that the two groups are independent, so you have to think about that. And then you check randomization 10% or random assignment for an experiment in each group, and check both histograms if they're unimodal or symmetric. Also on this sheet, you'll have to remember the degrees of freedom. One sample is n minus 1. Same with matched pairs. Independent groups, there's that massive formula. You'll just use the calculator for that. And then the last group, last part here is all from Unit 7. So for chi-squared test, we have goodness of fit. Degrees of freedom are number of cells minus 1. So we have to have counts in all of these. So make sure you have the categorical variable and your data is just counts of different answers. And then we check independent values with randomization and 10% or random assignment. And we check a large enough sample, but it's a little different. Instead of success failure is greater than or equal to 10, we check the expected counts and make sure they're at least 5. So just some subtle differences in the assumptions and conditions there. For homogeneity and independence, they're basically the same test, but remember, you'll probably be independence. And degrees of freedom are rows minus 1 times columns minus 1. And then the last one is the regression t-test. Degrees of freedom are n minus 2. We're testing to see if beta 1, the slope, is 0. So that means there would be no association as a null. The alternative is that there is. This is completely different. We go through the scatter plot check. So we check the scatter plot, make sure it's approximately linear. Then we do the regression, and we make the residual plot, and we check that the residuals are independent, which means there's random scatter in the residual plot. And the variability of errors is constant, which means there's no thickening or thinning. And then we check a histogram of the residuals and make sure that looks roughly unimodal and symmetric. Again, or you could check what's called a normal probability plot and see that it's reasonably linear. That fourth one is less important as n increases again, just like it is for the means up here, because the central limit theorem could apply. Any questions on the assumptions and conditions? All right, and on the other side just kind of shows you the standard error formulas again. They're kind of on your formula sheet, AP formula sheet, but worth looking at. Remember with proportions, we use p-hats for confidence intervals. For hypothesis tests, we use p sub 0, the null hypothesis proportion. So there's one group, there's two groups. If we're doing two groups, a two-sample z-test, or excuse me, a two-proportion z-test or interval, for the interval we use the sample proportions in the formula. Oops, right here. But in the hypothesis test, we have to find the pooled proportion. So the numerator in these two would be the same with different denominators. So keep that in mind. And then we have our formula for means, S over square root of n, and then the two-sample t-test. And then we have our formula for the chi-squared. And I wouldn't get too busy worrying about the regression formulas. That's pretty much going to be using everything from the calculator. Okay? Questions? So we'll talk more about the other parts, Unit 3, Unit 4, Unit 1, Unit 2. Well, probably not a whole lot with Unit 2 because we reviewed a lot of that with Unit 7, the regression t-test. But over the next week or so, we'll be reviewing Units 3, 4, and 1 quite a bit. Spending probably a day on Unit 1, a day on Unit 3, and then probably 2 days on Unit 4, probability. Okay? So to kind of finish up our review of Unit 7 for those who have the test to make up, and also give you an idea of what the tests look like and what you are expected to show for an inference type question, I'd like to show you a question from last year's exam. And this is all available to you. This is the AP Central. I just searched released AP statistics exams, and you can actually see last year's questions, how they scored them, only the free response. You can't see the multiple choice parts. Some years they release the multiple choice. And then they show scoring guidelines and sample students' responses and score distributions. So we'll kind of look at all these in some of this sample questions and score them over the next few weeks here. And maybe even do a practice test. Maybe set up a AP study session where we can do a practice test. But you can see, to do well on the exam, like this shows the last year's score distributions, the percent of people who got 5s, 4s, 3s, 2s, and 1s on the overall exam. Okay? Just because someone got a 5, that does not mean they got 100% on this exam either. Okay? So keep that in mind.